one of the beautiful subject known as chemistry, and our target is to achieve best marks in chemistry in the coming NEET examination, that is NEET 2022. So today I've decided to discuss one of the important chapter, that is structure of atom or atomic structure. Today is the first session and we'll see exactly how many sessions are required to complete this chapter. But yes, I'm going to discuss each and everything in detail from end to end. Okay, clear? So without wasting much time, let us quickly start the session. Okay. So proceeding further. Okay. If you are new to the channel, if you have yet not subscribed to the channel, then it's my recommendation, guys. It's my personal recommendation. Please make sure that you are going to subscribe our channel. Okay. And for the others who are actually following our channel, do not forget to like and share. Okay. Do like the video and share this YouTube channel amongst all your friends, those who are targeting NEET 2022 or NEET 2023. Okay. So that we can help them out to crack NEET examination. Clear? With respect to apart from this thing, guys, the Telegram link, okay, the Telegram group link is given already in the description box. Please go and click that link and join our Telegram channel as well, and Telegram, that is channel or a group as well, so that आपको सारे updates time पे मिलते रहेंगे. Okay, not only updates मिलेंगे आपको इसके साथ और क्या मिलेगा, हम जो भी PPTs यूज कर रहे हैं, जो भी presentations यूज कर रहे हैं, उसका PDF फॉर्मेट भी लिखा होगा annotations के साथ. मतलब हम जो भी लिखेंगे उसके साथ आपको क्या मिल जाएगा, एक नोट्स भी मिल जाएगा, तो नोट्स की भी टेंशन नहीं होगी. क्लियर? सो yet not done, yet not subscribe the channel, then please make sure that you are going to subscribe it, and do not forget to like, share and comment on the video. Let's get started. The first and the foremost thing that we need to discuss, okay, is what discovery of subatomic particles. Okay, discovery of subatomic particles. See, before this thing we talk about atoms. Okay, atom, the first one to give the idea about atom was an Indian, and he is known as Maharishi Kannad. Okay, around 300 BC में उन्होंने दिया था. Okay, उन्होंने क्या बोला था, if you take a पदार्थ, okay, पदार्थ is nothing but any substance and you start breaking it. मतलब कोई भी एक पदार्थ ले लो, something like this. Okay, कोई भी एक पदार्थ मतलब कोई भी एक substance ले लो, इसको तोड़ते जाओ. ओके, तो ये छोटा छोटा टूटते जाएगा. ओके ओके, देन फाइनली अ स्टेज विल कम व्हेन दैट पर्टिकुलर थिंग विल बी इनविजिबल, यू वोंट बी एबल टू सी, और दैट पर्टिकुलर स्टेज उसको आप और ज्यादा तोड़ नहीं पाओगे. सो दिस वाज पदार्थ, दैट इज नथिंग बट सब्सटेंस, एंड हियर ही सेड अबाउट परमाणु. आई होप द स्पेलिंग इज राइट. ठीक है, तो ये उन्होंने बोला था. देन यस, और भी बहुत सारे इंग्लिश साइंटिस्ट आए, उन्होंने भी नाम दिया, बट यस आई एम नॉट गोइंग इनटू दैट थिंग. देन डाल्टन केम एंड ही गेव हिज डाल्टन एटॉमिक थ्योरी, ओके, क्लियर. नाउ आफ्टर दैट डाल्टन एटॉमिक थ्योरी, व्हाट केम इज द डिस्कवरी ऑफ सबएटॉमिक पार्टिकल्स. so before starting the session, let us think upon one thing, that कि क्या एटम पहले आया या इलेक्ट्रॉन का पता पहले चला. राइट, एटम्स पहले आया या इलेक्ट्रॉन्स का पता पहले चला. ओके, अगर ये सवाल अगर मैं तुमसे पूछूं कि व्हाट इज द बेसिस, ओके, हमें सबसे पहले पता किसका चला, एटम के बारे में या सब एटॉमिक पार्टिकल्स के बारे में. द आंसर हमेशा क्या होना चाहिए, सब एटॉमिक पार्टिकल्स के बारे में, एटम के बारे में नहीं. बिकॉज ये आज तक जो भी कुछ कही गई है, ओके, देयर इज नो प्रैक्टिकल एविडेंस, या इन्होंने भी जो भी कहा, परमाणु कहा, एटम कहा, ठीक है, जो भी इन्होंने कहा, दैट वाज मियर अ स्पेकुलेशन. देयर वाज नो कॉन्क्रीट एक्सपेरिमेंट दैट प्रूव्स दैट एटम एग्जिस्ट. क्लियर? श्योर. बट जब डिस्कवरी ऑफ सब एटॉमिक पार्टिकल्स हुए, व्हेन द सब एटॉमिक पार्टिकल्स वाज डिस्कवर्ड, तब हमें एक कॉन्क्रीट प्रूफ मिला दैट एन एटम कंसिस्ट ऑफ सब एटॉमिक पार्टिकल्स लाइक इलेक्ट्रॉन, प्रोटॉन एंड न्यूट्रॉन. इसके अलावा भी बहुत सारी चीजें हैं, बट अपना फोकस किस पे होना चाहिए, यही तीनों चीजों पे होना चाहिए. ठीक है, clear? So that was the concept of discovery of subatomic particles. Proceeding further, we'll be discussing discovery of electron and the discovery of electron. Okay, although for the credit goes to what, the credit goes to whom? Sir okay, so the discovery of electron, the credit goes towards Sir J.J. Thomson. Okay, but सबसे पहले इस एक्सपेरिमेंट को किया था विलियम क्रुक्स ने इन अ डिस्चार्ज ट्यूब. ओके, द एक्सपेरिमेंट इज नोन एज व्हाट? डिस्चार्ज ट्यूब एक्सपेरिमेंट. ओके, यहाँ पे सबसे पहली चीज जो इंपॉर्टेंट होती है वो ये समझना कि डिस्चार्ज का मतलब क्या होता है. व्हाट डू यू एग्जैक्टली मीन बाय डिस्चार्ज? द बेस्ट एग्जांपल दैट आई कैन गिव इट टू यू रिलेटेड टू डिस्चार्ज इज व्हाट? लाइटनिंग. ओके, द बेस्ट एग्जांपल दैट आई कैन गिव इट टू यू इज व्हाट? लाइटनिंग. ठीक है, जब भी बारिश होती है तो लाइटनिंग होती है. ठीक है, बिजली कड़कती है. दैट इज व्हाट? इट इज अ डिस्चार्ज ऑफ इलेक्ट्रिसिटी इन द एब्सेंस ऑफ एनी मीडियम. इन द एब्सेंस ऑफ व्हाट? एनी मीडियम. दैट इज नोन एज व्हाट? डिस्चार्ज. जब भी आगे बहुत ज्यादा पोटेंशियल डिफरेंस का इलेक्ट्रिसिटी विदाउट एनी मीडियम की पास करने की कोशिश करोगे या हवा में पास करने की कोशिश करोगे, व्हाट कॉजेस इट? डिस्चार्ज. द सेम एक्सपेरिमेंट वाज डन, परफॉर्म्ड बाय विलियम क्रुक्स. ओके, सो लेट अस सी एग्जैक्टली ये एक्सपेरिमेंट क्या था. Okay, let us see exactly a experiment क्या था. This discharge tube experiment consists of a discharge tube or Crookes tube. Okay, ये जो है वो क्या है? इसको हम बोलते हैं discharge tube और Crookes tube. This discharge tube was connected with an outlet. Okay, that was connected to a vacuum to evacuate all the gases which is present. Okay, एक vacuum setup किया था किस लिए? So that all the gases, जितने भी gases है इसमें present, इसको क्या किया जा सके? बाहर निकाला जा सके. ठीक है, एंड इवन अगर कोई गैस रह गया है तो वो इतने कम प्रेशर पे रह गया कि उसको हम लोग नेग्लिजिबल मान सकते हैं. सो इवन इफ गैस इज प्रेजेंट, इट इज प्रेजेंट इन द प्रेशर ऑफ 10⁻² to 10⁻⁴ atmospheric pressure. Okay, and then in this discharge tube, two rods were connected. Okay, two rods were placed, that is cathode and anode, and they were connected to the battery which has a very high voltage. See, voltage देखो कितना, 10 kilovolts means 10,000 volt. Clear? So this is the experimental setup of what? Discharge tube. Okay, so जब ये experiment perform किया गया, the experiment was performed in dark. Okay, experiment, you should know this thing. Experiment was performed in dark room. Okay, so when this experiment was performed, it was found that there is some spark. Okay, there is some spark, there is some luminescence in this region. क्या देखा गया? Lightning देखी गई, luminescence देखा गया. Luminescence is nothing but lightning. Okay, so there was lightning coming out from this टेस्ट ट्यूब. मतलब इमेजिन कर लो कि डार्क रूम में हम ये एक्सपेरिमेंट कर रहे हैं एंड जैसे ही बैटरी कनेक्ट हुई, हमने स्विच ऑन किया, you find that there is some spark, there is some lightning coming. Okay, right? And that spark, that lightning made scientists to think exactly what was that. Okay, उसका nature क्या है? What is the nature of that spark? Is it a particle like a substance or it is a wave like a substance? Okay, so dual nature के बारे में भी हम आगे जाके एटॉमिक स्ट्रक्चर पे बात करते हैं. जो रिपीटर्स है या जिन्होंने एटॉमिक स्ट्रक्चर पढ़ा है, वी नो दैट इलेक्ट्रॉन हैज अ डुअल बिहेवियर. ओके, आप जो उसका देखने की कोशिश करोगे वो मिलेगा. लाइक इफ यू वांट टू स्टडी अ डुअल, यू वांट टू स्टडी अ वेव नेचर ऑफ इलेक्ट्रॉन, you go with accordingly with that kind of experiment. You want to study the particle nature, you can go with that kind of experimental element. But yes, that was the basis of what? That was the basis of what? Discovery of electrons. Okay, then उसके नेचर के बारे में जानने के लिए, उसकी प्रॉपर्टीज जानने के लिए बहुत सारी चीज़ें की गई. राइट, पहले तो ये पता किया गया कि ये कैसे जा रहा है. इज इट लाइक मूविंग इन अ स्ट्रेट लाइन और इज इट लाइक मूविंग इन एवरी डायरेक्शन या एग्जैक्टली व्हाट. ओके, तो पहले ये पता चला गया. देन उसका नेचर क्या है? पॉजिटिव नेचर है या नेगेटिव नेचर है? कहाँ से जनरेट हुआ, वो कहाँ पे जा रहा है? ओके, डज इट हैव सम मैकेनिकल प्रॉपर्टी और नॉट? ओके, तो ये सारी चीज़ें डिस्कस की गई. ओके, मैं उसमें ज़्यादा डिटेल्स में नहीं जा रहा हूँ, बट ये सारे पॉइंटर्स हमने मार्क किए. सबसे पहले ओके, द फर्स्ट पॉइंटर दैट यू शुड नो इज, सी, कैथोड रेज, जिसको हम CR भी कह सकते हैं. ओके, कैथोड रेज start from cathode, please make a note of it. Cathode rays starts from cathode and move towards anode. ठीक है, मतलब ये जनरेट कहाँ से हुआ? कैथोड से. मूव कहाँ से हुआ? एनोड से. क्लियर, मतलब नेगेटिव साइड से जनरेट हुआ और पॉजिटिव साइड जा रहा है. सेकंड, cathode rays travels in a straight line. Okay, cathode rays travels in a straight line. Okay, इसको कैसे पता चला गया कि travels in a straight line? What they did, बीच में कोई तो भी ऑब्जेक्ट रखा, dense object. Like for an example, suppose this dense object is kept. Okay. Okay, so this dense object was kept. Okay, so जैसे ही वापस से एक्सपेरिमेंट किया गया, we found that there is a shadow. Okay, पीछे अपने को क्या मिला? Shadow. This is what? Shadow. Which proves that this particles or this lightning or whatever it is that it is passing in a straight line. Okay, and they term that thing as a cathode ray. So cathode ray starts from cathode, moves towards anode. Second उन्होंने क्या बोला? Cathode rays travels in a straight line with a very high velocity. How we can say that high velocity? Because जैसे ही ये ऑब्जेक्ट को बाहर निकाला गया, it was found to be hot. And we know that जब भी एक फास्ट मूविंग ऑब्जेक्ट किसी पार्टिकल लाइक जब भी कोई फास्ट मूविंग ऑब्जेक्ट किसी भी सरफेस से टकराता है तो इट प्रोड्यूसेस हीट. ओके, एंड द बेस्ट एग्जांपल जो मैं तुम्हें दे सकता हूँ कि हाई मूविंग ऑब्जेक्ट व्हेन स्ट्राइक इट प्रोड्यूसेस हीट इज, सब लोगों लाइक इसका एक बेस्ट एग्जांपल जो मेरे दिमाग में आता है वो मेरे बचपन से ना कि सबके बचपन से, मम्मी के माँ के हाथ का मार तो सबने खाया होगा, राइट? सब लोगों को मार तो पड़ी होगी, ठीक है? तो जब भी मम्मी का हैंड स्टेबल है, दैट मम्मी का जो हाथ है वो क्या ऑब्जेक्ट है, ठीक है? वो हाथ उठा और स्ट्राइक किया, कहाँ पे? गालों पे. तो उसके बाद जैसे ही तुम हाथ रखते हो तो क्या फील होता है? इट फील्स हॉट. ओके, क्लियर? सो व्हेनेवर अ फास्ट मूविंग ऑब्जेक्ट कम्स एंड स्ट्राइक इट फील्स हॉट. ओके, सो दैट्स व्हाई वी कैन से दैट दैट्स एन हाई वेलोसिटी. अगर मम्मी प्यार से मारेगी तो कुछ फील नहीं होगा, ठीक है? बट येस, स्पीड से आया हाथ, दाड़, हाँ, बहुत गरम गरम फील होता है, ठीक है? सो दैट इज अ बेसिक थिंग. क्लियर? सो कैथोड रेज ट्रैवल इन अ स्ट्रेट लाइन विद अ वेरी हाई वेलोसिटी, ठीक है? दैट वाज प्रूवन बाय बिकॉज द ऑब्जेक्ट वाज हॉट. और भी हम कह सकते हैं, ठीक है? बीच में उन्होंने क्या रखा? एक पिन व्हील रखा. पिन व्हील क्या होता है? मेले में सब लोग गए होंगे, राइट? मेले में देखो एक कुछ इस तरह का कार्टव्हील टाइप मिलता है, समथिंग लाइक दिस, पंखे जैसा बना हुआ, और एक लकड़ी, सॉरी, एक लकड़ी से लगा होता है, पिंड होता है वो बेसिकली, राइट? एंड बच्चे लेके घूमते हैं तो वो घूमना चालू करता है. सो व्हेनेवर व्हेन दिस पिन व्हील वाज केप्ट इन द डायरेक्शन और इन द व्हाट वी से in that direction, so it started moving. It started what? Moving. आगे वो वाले भी डिस्कशन आएंगे. Clear? Hello Dhruv, welcome to the session. Third, in the presence of electric field, okay, in the presence of electric field, cathode rays deflects towards positively charged plate. ओके, तो जब भी इलेक्ट्रिकल फील्ड के बारे, इलेक्ट्रिक फील्ड में उसको रखा गया तो कैथोड रे कहाँ पे डिफ्लेक्ट किया? टुवर्ड्स पॉजिटिवली चार्ज प्लेट. सो मान लो यहाँ से ये जो रेड कलर लाइन है, कैथोड रे आया. सिंस देयर इज इन प्रेजेंस ऑफ ओनली व्हाट वी से मैग्नेटिक सॉरी इलेक्ट्रिक फील्ड, सो इट स्ट्राइक्ड एट ए पॉइंट ए. देन हमने क्या किया? इलेक्ट्रिक फील्ड हटा लिया और मैग्नेटिक फील्ड प्लेस किया, मैग्नेटिक पोल. ओके, सो इन द मैग्नेटिक फील्ड इट वाज फाउंड दैट इट हिट टुवर्ड्स द साउथ पोल. तो ये कहाँ पे आके लगा? साउथ पोल पे आके लगा. जब दोनों को ही हमने साइमल्टेनियसली अटैच किया परपेंडिकुलर, मतलब मैग्नेटिक फील्ड ऐसे, या मान लो इलेक्ट्रिक फील्ड ऐसे लगा हुआ है तो मैग्नेटिक फील्ड ऐसे लगा हुआ है, तो परपेंडिकुलर जब भी हमने प्लेस किया एंड दोनों का स्ट्रेंथ बराबर कर दिया, ओके, देन इट वाज फाउंड दैट कि उसने बिना कोई डिफ्लेक्शन किए जाके कहाँ लगा? पॉइंट बी पे लगा. एंड दिस एक्सपेरिमेंट फॉर्म्स द बेसिस, ओके, forms the basis on which J.J. Thomson has derived some equation related to charge by mass ratio. उसके ऊपर भी हम जल्दी आएंगे. But yes, this experiment was the basis. ठीक है? Let's move forward. Cathode rays produces X-ray. Okay, when they are made to fall on a metal surface. So please make a note of it. Whenever cathode rays, what we say, strikes. Okay, whenever cathode rays strikes on a metal surface, it produces what? X-rays. Okay, clear? Next. 6. Special charge is independent of, not special, sorry, specific charge Okay, the specific charge of this cathode rays it is independent of what nature of cathode rays and the number and the nature of the gas present in cathode ray tube. तो आप कोई भी metal ले लो, take whatever metal you have to take, okay, take any gas in the chamber, its specific charge will remain constant, okay, and hence that proves that electron is considered to be what, the constituent particle of all atoms. Okay, और भी कुछ पॉइंटर्स है. कैथोड रेज हैव अ पेनिट्रेटिंग पावर. कैसे पता चला? इसके पीछे हमने फ्लोरेसेंस ट्यूब रखा. ओके, फ्लोरेसेंस व्हाट इज इट, फ्लोरेसेंस मटेरियल जो ट्यूब था. ओके वेट अ सेकंड, या ये जो एनोड के पीछे का जो ट्यूब वाला हिस्सा था हमने उसको क्या कर दिया, कलर कर दिया. कलर कर दिया एज इन हमने किसके साथ कोट कर दिया, जिंक सल्फाइड के साथ और फ्लोरेसेंट स्क्रीन के साथ. ठीक है, व्हाट इज अ फ्लोरेसेंट स्क्रीन? फ्लोरेसेंट स्क्रीन is a particular object on which if a high moving charge particles collide it will produce scintillation. ग्लो करना चालू करेगा. वो क्या करना चालू करेगा, ग्लो करना चालू करेगा. ओके, सो दैट थिंग वाज ऑब्जर्व्ड व्हेन कैथोड रे, जैसे एक्सपेरिमेंट स्टार्ट किया गया, इट नॉट ओनली मूव फ्रॉम कैथोड टू एनोड बट एक्चुअली इट इज व्हाट penetrating anode and is giving scintillation behind anode. So yes, it has a penetrating power as well. Clear? Sure. Now, charge on electron. The charge on electron was given by what? R.M. Millikan by oil drop experiment to determine the charge on electron. So, talking about the charge on of electron, you have to remember this thing. It is minus 1.6 into 10 raised to minus 19 coulombs or minus 4.8 into 10 raised to minus 10 electrostatic unit. Please इसको याद करना. Please remember this value. Okay, clear? Next. In 1897, the British physicist Sir J.J. Thomson studied the deflection of cathode rays under the simultaneous, see remember, simultaneous application of electric and magnetic field. मैंने पहले ही बताया. The derivation is none of our concern, and finally after derivation what is said that the charge of electron to the mass of electron, the ratio comes out to be this 1.758 into 10 raised to 11 charge per coulomb per kg or coulomb per gram. Now we know the charge of electron, right? By Millikan experiment we know the charge of electron, we know the ratio of charge by mass ratio of the electron, right? Can we calculate the mass of electron? Answer is yes, and with this equation the value was calculated as this. The mass of electron comes out to be 9.1 into 10 raised to minus 31 kg, or you can also say mass of electron is minus sorry, not minus, it is 9.1 into 10 raised to minus 32 kg. Clear? Sure. Okay, if anyone has any doubts please post it in the chat box. Next, talking about discovery of proton. Okay, talking about what? Discovery of proton. It was the same thing. The only thing that was changed was perforated tube. Okay, because अगर perforated नहीं ले रहे तो scintillation नहीं हो रहा था, and अगर scintillation नहीं हो रहा था so we were not getting any idea कि whether like cathode rays, anode rays exist or not. Okay, जैसे कैथोड रे था वैसे कोई एनोड रे एग्जिस्ट करता है या नहीं करता है, वो कैसे पता चला? आफ्टर टेकिंग अ परफोरेटेड ट्यूब. अगर हम परफोरेटेड ट्यूब सॉरी, if you don't take perforated tube, that we won't be able to know whether it exists or not. Clear? Sure. Rest everything is same. Anode ray starts from anode and move towards what? Cathode. Anode rays travel in a straight line. In the presence of electric field, it get deflected towards negatively charged species, negatively charged plate. Magnetic field towards north pole. Okay, but yes, the charge by mass ratio for anode ray is not same. If you change or if you keep on changing the metal or the gas, the charge by mass ratio for anode rays keeps on changing. Okay, clear? And this charge by mass ratio of anode ray, okay, was found to be maximum when hydrogen is taken. Okay, so see, the charge by mass ratio of anode rays changes with the nature of gas. Okay, the charge of anode rays is exactly opposite of cathode rays. Okay, this is positive, not negative. It is positive 1.6 into 10 raised to minus 19. Okay, then the mass of proton is this much, 1.67 into 10 raised to minus 27 kg, and the charge by mass ratio is 9.58 into 10 raised to minus 7 kg. Please make a note of it. Mass of proton or mass of anode rays is equal to 1836 times mass of electron or mass of cathode rays. Clear? Proceeding further, discovery of neutron. The neutron discovery was done by James Chadwick in 1932, and this was the experiment. He bombarded an alpha particle on beryllium, what was found to be forming of carbon. Okay, so if we'll see 2 plus 4, 6, but 4 plus 9 should be 13, but we know that carbon mass is 12. So there is one species that was eliminated during this reaction, which has, okay, what we can say, which does not have any mass. Okay, which does not have any what? Mass. So you have to make sure that. So no charge basically. Clear? Sure. Wait, this is I guess wrong. This should not be the representation. It has to be N01. Okay, which has mass. Okay, which has mass but no charge. It is neutral. Clear? That means it will not get deflected in any of the field. Is that thing clear? Okay. Next. Properties: no charge, mass of electron is slightly, okay, mass of neutron is slightly higher than the mass of proton, and that can be proven by mass of neutron is 1837 times mass of electron, whereas mass of proton is equal to 1836 times mass of electron, and hence that proves that mass of neutron is slightly more than mass of proton. Clear? Sure. Proceeding further towards the atomic models. Okay, the first one, okay, the first atomic model was given by Sir J.J. Thomson itself, and that model is known as plum pudding model or watermelon model or choco chip cookie model, whatever you can say. In that thing, the edible part, the red color part, okay, here also this red color biscuit part, not the choco chips. Okay, I'm talking about the biscuit part. They are termed as what? A positively charged species. That is nothing but proton. And the electrons are embedded in it like the seeds in watermelon and the choco chip in this cookie. Is that thing clear? That is plum and pudding model. Although this model does not hold good and it was discarded soon, but the only thing that it was achieved was electrical neutrality. Thomson atomic model was known for its electrical neutrality. Okay. Next, talking about the setup. Okay. Sorry, what setup? After that, let us talk about the Rutherford atomic model. I directly started. Okay, there is some mistake. So we are talking about what? Rutherford. Okay. Alpha. Rutherford alpha scattering experiment. Okay, so if I talk about the setup for the Rutherford alpha scattering experiment, first of all, it consists of a lead block. Okay, it consists of a what? Lead block. Why lead block was considered or why lead block was used? Because it is dense. Because it is what? Dense. Second, that lead block, okay, in this lead block there was a cavity that will be placed, like this cavity, something like this. The cavity was placed, and inside that cavity what they kept was a radioactive material that emits alpha particle. Okay, so that is what? Source of alpha particle. Let me just give you some idea about alpha particle. So alpha particle is nothing but helium nuclei. That means it has charge, okay, sorry, it has mass 2 and charge, mass 4 and charge 2. Okay, that is helium 2 plus. Clear? Whose atomic number is 2 and mass is 4. Is that thing clear? So that source was kept. Okay, then there was a slit that was present. This is what? A slit made up of again what? Lead, that will allow, okay, that will allow a single beam to pass through it. Okay, then at the center, okay, that alpha particle was allowed to at the what? Hit at the center of the gold foil, a very thin gold foil. The thickness was around 100 micrometer or 0.1 nanometer. around 0.1 nanometer, something like this. Okay, the thickness was something like this. Okay, and the entire setup was covered with what? Fluorescent screen. The entire setup was covered with what? Fluorescent screen. Clear? Sure. So this is the entire setup. Proceeding forward, if I talk about the first observation, most of the alpha particle, okay, approximately 99% went straight without any deflection. It went straight without any deflection. Okay. Second observation, okay, there were very less alpha particle that was deviated by what? A small angle. So see, deviated by a small angle. Okay. Very less alpha particle was deflected by a very large angle. See this blue color line, large angle. Okay, this is positive charge over here. Okay, and 1 in 10, 1 is 10,000 or 20,000 mostly. 1 in 20,000 alpha particle was bounced back, retraced its path, something like this red color. It came, bang on, direct collision, it went back. Okay. So all this thing first of all gives us an idea that there is something positively charged species that is present that is causing this deflection. Why? Because the positive and positive will repel each other. Okay, clear? Second thing, and since most of the alpha particles are going straight, it simply means what? What is the basic thing, or what is the conclusion of this thing? That the atom is completely hollow or completely empty, and its mass is concentrated at one particular center that he named as nucleus. Is that thing clear? Sure. So yeah, that's all the things that I have written over. Whatever we have discussed, we have written over in terms of pictorial view. You'll get this thing. Let's proceed further. Okay, now the entire mass of the atom is concentrated in a small region which has a positive charge, and Rutherford named this thing as nucleus. And Rutherford named this thing as what? Nucleus. Clear? Now, what are the achievements? The first achievement is what? Discovery of nucleus. Okay, the credit goes to what? Rutherford. Second, he also gave some relationship between the radius of nucleus, okay, and nuclei as well. Okay, atom and nuclei basically. So radius of nucleus R is R naught times A raised to 1/3. Okay, 1/3 of its atomic mass, where A is what? Atomic mass, and R naught is a constant and generally taken as 4/3 into 10 raised to minus 13. Okay, clear? Sure. Third, he also calculated order of radius of atoms and nucleus. He also calculated what? Order of radius. So radius of atom is in the order 10 raised to minus 10 meters or 10 raised to minus 8 centimeters. Whereas radius of nucleus is 10 raised to minus 15 meters or 10 raised to minus 13 centimeters, or 1 Armstrong, 1 Fermi meters. Clear? Got it? On the basis of this thing, we can calculate something. Okay, that is, let us calculate the volume of nucleus to the volume of atom. So volume of nucleus, okay, calculate the ratio of volume of nucleus to volume of atom. Okay, both are spheres, so it is 4/3 pi r cube, but here I am going to take radius of nucleus whole divided by 4/3 pi r cube. Here I am going to take radius of atom, 4/3 pi, 4/3 pi will get cancelled. That is equal to what? Radius of nucleus whole divided by radius of atom raised to cube. What is radius of nucleus order? Can I say it is radius of nucleus is around how much? 10 raised to minus 15 whole divided by 10 raised to minus 10 the whole cube, right? That is equal to what? 10 raised to minus 5 the whole cube. That is equal to what? 10 raised to minus 15. So here, can I say that volume of nucleus is equal to 10 raised to minus 15 times volume of atom? 10 raised to minus 50 times minus 15. Okay, that is 0.1401. That is the ratio between volume of nucleus and volume of atom. Or other way, if you want to know volume of atom, it is 10 raised to 15 times volume of nucleus. It's like placing a tennis ball at the center of a entire stadium, cricket stadium. Placing a tennis ball in the center of the entire cricket stadium. It is that difference. Okay, so nucleus is tennis ball, whereas the entire stadium is what? Atom. It is so hollow. Clear? Sure. Perfect. The last one, what is said, that the number of alpha particles scattered is inversely proportional to the fourth power of sine theta by 2. So we can just understand that the number of alpha particle scattered is inversely proportional to sine sine 4 theta by 2. Sine raised to 4 theta by 2. Clear? Done. Now, talking about what are the drawbacks. Okay. Now see guys, whenever you do any research or anything, it's not directly it will get published. ऐसा कभी नहीं होगा कि डायरेक्ट क्या हो जाए वो पब्लिश हो जाए. What basically we do, whatever research and whatever findings we have, we bring that research or that finding in front of a committee. Okay, that committee consists of all physicists and chemists of that particular time and still today as well. Okay, and then you have to keep on explaining what exactly you did, what was the observation you had, and what is the conclusion. After listening to your entire presentation, what they will do, the brilliant minds over there, what they'll do, they'll use their brain and they'll ask you some questions. Okay, they'll ask you any questions on whatever experiment you have done, and once they are satisfied with their question, then your achievements are published. Is that thing clear? So in the same way, when Rutherford exactly got all this observation and done all the calculation, he was ready for the same. So while discussing, okay, or before we go to that particular discussion, okay, after all these things, Rutherford suggested the atomic model. Okay, according to Rutherford, the atomic model will look like, okay, the atomic model will look like the mass of the entire atom is concentrated in a nucleus, which is certainly a positively charged, and electron revolves around the nucleus. Okay, electron revolves around the nucleus. This was the idea, or this was the model. Okay, this was the model that was suggested by whom? Rutherford. Okay, then while he was suggesting this particular model, okay, there comes the first thing. Okay, the moment he said that the electron revolves around the nucleus, okay, then someone raised his hand, and what he said was, Sir Rutherford, if you are saying so that the electron is taking a circular path across the nucleus, then if I apply the concept of Maxwell theory of electromagnetic radiation, which simply says that if a charged particle is accelerated, it will continuously lose energy. Okay, and if you apply this theory on your model, then can I say that there will be a time coming, okay, there will be a time coming, because this what we say, in spite of that circular path, it is forming a spiral path. Why? Because as it is what accelerated across the circle, okay, it will continuously keeps on losing energy, and since it keeps on losing energy, so in spite of circular path, it will keep on having a spiral path. It will keep on having what? Spiral path. And since it is forming a spiral path, a time will come when this negative charge will drop in nucleus, and hence the atom will be unstable. So can you explain why this theory is not applicable to your model, or what is the exact phenomenon? Rutherford does not have the answer for it. And to be honest guys with you, all of you, ये concept यहाँ पे लगाना ही नहीं चाहिए था. I am not saying Maxwell theory of electromagnetic radiation is wrong, but application of Maxwell electromagnetic radiation on Rutherford model was wrong. ठीक है, मैं ये नहीं कह रहा हूँ कि इलेक्ट्रोमैग्नेटिक रेडिएशन थियरी गलत है, नहीं, इसको यहाँ पे अप्लाई करना गलत था, जो आगे जाके प्रूफ भी हुआ. Is that thing clear? Sure. Got it. So yeah, that was very much important first limitation. What was that? Why electron does not perform a spiral path? And what about the stability of atom? Because if it performs a stable path, if it performs a spiral path, the atom is not stable. Okay, clear? Second, तभी किसी ने नहीं पूछा, बट आगे जाके इसका ये दूसरा ड्रॉबैक बना. दैट वाज नथिंग बट स्पेक्ट्रम. ओके, स्पेक्ट्रम क्या है? इट इज अ रिप्रेजेंटेशन ऑफ वेवलेंथ ऑन अ पीस ऑफ पेपर. ओके, it is what representation of a wavelength on a piece of paper that was done by spectrophotometer. Clear? बट उसके बारे में हम ज़्यादा डिटेल में बाद में बात करेंगे, तो पहले ड्रॉबैक देख लेते हैं. ओके, सो ये यहीं पे इस चीज़ को मैं प्रूफ कर देता हूँ यहाँ पे कि वाई इलेक्ट्रोमैग्नेटिक रेडिएशन नहीं लगाना चाहिए, तो वो यहाँ पे पता चल जाता है. ओके, अकॉर्डिंग टू मैक्सवेल, एनर्जी इज एमिटेड कंटिन्यूसली, राइट? अच्छा, एनर्जी इज एमिटेड कंटिन्यूसली मतलब स्पेक्ट्रम क्या होना चाहिए? ओके, स्पेक्ट्रम बेसिकली होता क्या है? कोई भी एनर्जी अगर रिलीज होगी तो उसका एक वेवलेंथ होगा, और जैसे ही एनर्जी रिलीज होती है एक लाइन आती है. ओके, तो सपोज इफ दिस इज अ पेपर, दिस इज अ वाइट पेपर, सपोज इफ एनर्जी इज रिलीज, इट विल शो यू वन लाइन, एनी कलर लाइन बेसिकली. देन अगेन, तो जितनी एनर्जी रिलीज होगी उतनी लाइन्स क्या होती आते जाएंगे. सो अगर मैक्सवेल का थियोरी यहाँ पे अप्लाई करना सही है, तो अकॉर्डिंग टू मैक्सवेल क्या बोला था उसने? कंटिन्यूस होना चाहिए. तो सी स्पेक्ट्रम कैसा होना चाहिए था? कैन आई से दैट सिंस एनर्जी इज emitted continuously, the spectrum should look like energy. Can I say it will look something like this? कैसा दिखना चाहिए स्पेक्ट्रम? ऐसे एनर्जी 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 एनर्जी. दिस इज अ स्पेक्ट्रम कंटिन्यूसली सिर्फ लाइन आते जा रही. बट एक्चुअली जब एटॉमिक स्पेक्ट्रम निकाला गया, इट वाज फाउंड दैट एनर्जी 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 एनर्जी, इसका मतलब क्या है? डिसकंटिन्यूस मिला. जब स्पेक्ट्रम एक्चुअली निकाला गया तो ये क्या था? डिसकंटिन्यूस. बट हमने क्या बोला उसके ड्रॉबैक के लिए? सिंस इलेक्ट्रॉन इज एक्सेलरेटेड, इट विल लूज एनर्जी कंटिन्यूसली, फॉर्मिंग अ स्पाइरल पाथ, एंड हेंस एटम विल बिकम अनस्टेबल, जो सही नहीं था. अल्टीमेटली जाके यही पता चला कि इट इज अ डिसकंटिन्यूस स्पेक्ट्रम. बट अगेन रदरफोर्ड के पास इसका भी आंसर नहीं था. Clear? Sure. That was the two drawback. Okay, that was the two drawback of Rutherford atomic model. Clear? Sure. Proceeding further, let's see some question. Rutherford experiment, which established the nuclear model of an atom, used the beam of alpha particle. It used the beam of what? Alpha particle or helium nuclei. So beta particle? No. Gamma particle or gamma rays? No. Helium atom? No. We don't have helium atom. It is a helium nuclei. And hence last one is the right answer. Helium nuclei which impinged on metal foil and got scattered. Clear? Sure. Next. The radius of an atomic nucleus is our order. See, radius of atomic nucleus is that, and the order is 10 raised to and the order is in terms of centimeter. So for nucleus, you should remember it is 10 raised to minus 15 meters or 10 raised to minus 13 centimeter or 1 Fermi meter. Clear? Sure. So yeah, that is the case. So hence answer has to be option B in terms of centimeter. Next, Rutherford experiment on scattering of alpha particles show the first time that the atom has nucleus. Shows the first time that atom has nucleus. Got it? Next we'll talk about atomic number and atomic mass number. This is mass number A. Atomic number and atomic mass number A. Let us eliminate this thing completely. It is A. Okay, so any element, okay, so atomic number and atomic mass number. Before going to that, we need to discuss Moseley experiment. Okay, Moseley was one of the youngest chemists who actually has helped a lot in preparing of what modern periodic table, and his experiment is pretty much same enough. Okay, what he did, he allowed electron to follow on metal surface, which releases what? Alpha particles. which releases what? X-rays. And the wavelength of that X-ray he plotted against, okay, and the wavelength he did what? He plotted against frequency. Okay, clear? So when, okay, basically what he did, what? He plotted a graph of root of frequency versus Z, that is atomic number. Okay, and when he plotted the graph, it looks something like this. All the points lie on a single line. Okay, and hence he said that what? And hence he said that what? Actually, it is in what? What do you say? When he said that when a fast moving cathode ray particles is bombarded on atom or any metal surface, it knocks out the electron from the valence shell of an atom. Due to the removal of the electron, okay, due to the removal of electron, the electromagnetic radiation, okay, that is X-ray, has been emitted by an atom. With this thing mostly suggested an equation, okay, that is, it is directly proportional to what? Atomic number, not mass number. It is directly proportional to what? Number. And when he plotted the graph, it was straight line. Later on, he modified the equation where A and B are constant. Okay, clear? Now, talking about representation of element, okay, any element is represented in this way. Okay, any element is what? Represented in this way, where the bottom number always represent the atomic number. Okay, the number that is given at the bottom of any element is what? Atomic number, and at the top is what? Atomic mass number. And at the top is what? Atomic mass number. Clear? So let's get started. What is atomic number? It is the number of proton or number of electron in neutral atom. If you're talking about number of neutron, it has to be in what? A neutral atom. Clear? Sure. So for an example, nitrogen. Okay, if I write nitrogen 7 and 14, so this represents what? Atomic number Z. That means what? Number of proton over here is 7 and the number of electron over here is 7. Clear? Sure. Now talking about atomic mass number, okay, it is number of proton plus number of neutron. Like again, nitrogen 7, 14, right? So can I say that A is equal to what? Proton plus neutron. So neutron will be equal to what? A minus P. Okay, it will be what? A minus P, right? That is equal to, okay, can I say that over here proton is equal to how much? 14. Neutron is equal to how much? Proton. Electron is equal to how much? Extremely sorry guys. Proton is equal to how much? 7. Neutron is equal to how much? It is what? Atomic mass number. Atomic mass number is 14. So 14 minus 7 is 7. Okay, clear? So let us take this an example again. Oxygen. This is what? Z. This is what? A. So Z is equal to 8. A is equal to 16. That is atomic number is 8. Mass number is 16. Number of electron is equal to what? Z. That is equal to 8. Proton is again 8. And number of neutron is equal to how much? A minus P. That is equal to 16 minus 8. That is equal to 8. Clear? Sure. Next. Now, yeah. See, normally when I teach this thing, it feels like it is 9th and 10th standard concept. But see, in NEET 2020, the question that was asked, okay, NEET 2020, the question that was asked was the same question. Calculate the number of protons, neutrons and electrons. Okay. To save time, this is 71. So at the start 71, at the end 71. And the only option we have that thing is A. You don't need to calculate the number of neutrons. And if you don't have that such combination, then you can calculate number of neutron as well. You will get the same thing. Okay, 175 minus 71 is 104. Clear? Sure. Now, talking about the next thing, isotopes. What are isotopes? The element having what? Same atomic number but different atomic mass number. Okay, same atomic number and different atomic mass number. For an example, hydrogen, deuterium, tritium. Okay, right? So What is the representation? Can I say hydrogen can be represented as it has one proton and one electron, and its mass is what this. Okay, it can be represented as 1 2, can be represented as 1 3. That means over here proton is equal to electron, that is equal to 1, and neutron is 0, the only element which does not have any neutron. If I talk about deuterium, proton is equal to electron, that is equal to 1, and neutron is 1. Tritium, proton is equal to electron, that is equal to 1, and N is 2. That means isotopes will differ in the number of neutrons. Isotopes will differ what in terms of what neutrons. Similarly, if I take carbon 12, carbon 13, and carbon 14. Okay, right? So here number of neutron is 6, number of neutron is 7, and number of neutron is 8. Whereas number of proton and electron, okay, in the entire case, proton is equal to electron, that is equal to 6. Clear? Similarly, oxygen, O8, 16, 17, 18, right? And the number of neutrons over here is 8, 9, and 10, whereas electron and proton is over 8. The last one are radioactives. Okay, the last ones are what? Radioactive. So this is radioactive, this is radioactive, and this is radioactive. C14 is used for carbon dating. Okay, C14 is used for what? Carbon dating. And whereas O18 is used for tracing reaction mechanism. Tracing or formation of what? Reaction mechanism. Clear? Sure. So that is all about what isotopes. If I go forward, we'll talk about what isobars, which has same atomic number. Which has same mass number and different atomic number. Okay, same mass number and different atomic number. To see, different atomic number, same mass number. Different atomic number, same mass number. Same mass number. Same mass number. Clear? Sure. Next. Isotones. The word itself suggests tones means what? It will have same number of neutrons. It will have what? Same number of neutrons. Let us see. These are the example. Calcium and chlorine. So atomic mass number you can see 40 over here, 37 over here. Atomic number you can see 20 and 17. Minus, if I'll say what is neutron is what? A minus Z. This N will be equal to what? A minus Z. So A minus Z is what? 40 minus 20 is what? 20. 37 minus 17 is what? 20. So they are what? Isotones of each other. Similarly, can I say that the mass number is 23 and this is 24, this is 11 and this is 12. So what is the case? It is 23, 12 and 12. So again they are what? Isotones. So element having same number of neutrons are known as what? Isotones. Clear? Then comes isoelectronic species. That means they have same number of electrons. Now see how to understand this thing. Talking about Z, atomic number, nitrogen is 7, 8, 9, 10, 11, 12, 13, right? Okay. When there is negative charge, you need to add electron. When there is positive charge, you need to remove the electron from their atomic number. So negative charge is how much? 3. So 7 plus 3 is what? 10. 2 negative charge, 10. 1 negative charge, 10. No charge, 10. 1 positive charge, that means electron has to be removed, 10. 2 positive charge, remove, 10, 10. That means what? They all are isoelectronic to each other. Clear? Next. This was asked in NEET 2014. Okay. Be2 plus ion is isoelectronic with which of the following? Ideally, this should not be the answer, because this is sodium and magnesium. Okay, which is what? Sodium and magnesium is what? Third period element. whereas beryllium is second period, so almost there will be a difference of 8 electrons. Okay, talking about B2 plus, H plus cannot be the answer because it does not have any electrons. So the only option remains is what? This. B2 plus atomic number is how much? So atomic number is how much? 4. 2 electron is gone. So that means total number of electron is 2. Lithium atomic number is how much? 3. 1 electron gone. So again 2 electrons. So that's why it is isoelectronic. Next, isoelectronic species are. Okay, isoelectronic, you need to know what are the isoelectronic species. So see, carbon monoxide. We have carbon monoxide. Carbon has 6 electron, whereas oxygen has 8, so it becomes 14. Then Cn minus ion. See, Cn minus ion. Carbon has how much? 6, 7 and plus 1. Again 14. Then NO plus. NO plus. So nitrogen has how much? 7. This has how much? 8. So that is equal to what? Again 14. Right? Because 1 electron has to be removed. Then we have C2, 2 minus. C2, 2 minus. Okay. So carbon has how much? 6. 6 to the 12 and plus 2. So that is 14. So I'll go with option number 1. Clear? Sure. Next, the isoelectronic. Okay, the ion that is isoelectronic with CO. Okay, isoelectronic with CO means how much? 8 plus 6, 14 electrons. Cn minus ion, we have just seen that carbon is 6. Carbon is 6, nitrogen is 7 plus 1, that is equal to 14. So that will be the answer. Clear? Sure. Talking about isosters. What are isosters? These are the particular atom or an ion or a molecule which have same number of electron, atoms and similar shape. Their number of electrons, the number of atoms and the shape will be same. Talking about carbon monoxide and nitrogen, they both have 2 atoms. If I talk about carbon monoxide and nitrogen, they both have 2 atoms. Here also 2 atoms. Irrespective of whatever, same or different atoms, but they have 2 atoms. Clear? Sure. Then what is the structure? C triple bond O. Right? What is the structure? N triple bond O. They have same structure, same shape. Number of electrons. We know that 8 plus 6 is how much? 14 electrons. 7 and 7 how much? 14 electrons. So that's why they are all isosters of each other. Okay. Clear? Next, isodiaphers. Okay, if I talk about isodiapher, their isotopic number is same and isotopic number is calculated as this. So let us talk about chromium and copper. Okay, their A value. Atomic mass number is how much? 54 chromium and 64 copper. Right, their atomic number is how much? 24, 29. Then twice of Z is how much? Okay, so it is 48 and this one will be 2 9 the 18, 58. So A minus 2Z is how much? A minus 2Z is how much? Okay, so it is A minus Z. So it is approximately how much? 6. This is approximately how much? 6. So they are same isotopic number and hence they are what? Isodiaphers of each other. Clear? Sure. Next. Okay. Isotone of germanium 3276 is, so germanium 3276. So 76 minus 32 is how much? 44. So we need to know 44 value. 77 minus 32 is 45, not the right answer. 76 minus 33 is 43, not the right answer. 77 minus 34 is again 43, not the right answer. 78 minus 34 is 48, best answer. Clear? Sure. Perfect. Now, the sum of number of neutrons and protons present in isotopes of hydrogen. Sum of number of neutron, proton present. Okay, sum of number of neutrons, protons present in isotopes. Okay, so talking about hydrogen. Okay, let us go in a tabular form. So it is proton, neutron, proton, and hydrogen 1 0. So 0 neutron, 1 proton. 1 neutron, 1 proton. 2 neutron, 1 proton. What is the answer? Sum of neutrons and protons. 3, 3 plus 6. 6 is the right answer. Clear? Sure. Right. Now talking about developments of Bohr order, the first one is electromagnetic radiation. We know that it travels perpendicular to each other. That's the only thing you should know. It travels what? Perpendicular to each other. And we have some characteristics that we need to discuss. Amplitude is what? It is the maximum displacement. That is this. Okay, it is the maximum displacement from its mean position. That is amplitude. And its unit is what? Meter, centimeter. Okay. Wavelength. It is the distance between the two crest, two troughs, or one crest and one trough. So this is wavelength, the length of an entire wave, which is given by lambda. Okay, generally it is calculated in Armstrong, and we know that 1 Armstrong is 10 raised to minus 10 meters. Okay, clear. Next, time period. It is a time taken to complete one oscillation. That means starting from point A to reach to point B from this way. Okay, this wave, how much time is taken, it is known as what? Time period. Okay. Frequency, it is the number of oscillation per unit time. So frequency is basically equal to what? 1 by time. Okay, clear. And its unit is hertz or per second or second inverse. Okay. Speed is what? Speed is what? Speed is equal to distance by time. Over here distance is lambda, time is t. Speed is nothing but electromagnetic radiation. The speed is equal to speed of light. So c is equal to lambda by t. 1 by t is equal to what? Frequency. So c is equal to what? Lambda times frequency. That means the combination, any electromagnetic radiation, okay, you take off any wavelength and frequency, you have to make sure that the product has to be what? Equal to what? Speed of light, that is 3 into 10 raised to minus 8. With this thing, you should also know one thing: frequency is inversely proportional to lambda. That means if lambda is more, frequency is less, right? And if frequency is more, lambda will be less. Clear? They are inversely proportional to each other. The last one is wave number. Okay, it is the number of waves present in 1 meter length. It is number of waves present what? In 1 meter length. So wave number is equal to what? 1 by lambda. That's it. Okay. Is that thing clear? Sure. Now let us solve some questions. Calculate the wave number and frequency of yellow radiation having wavelength this thing. What we need to calculate? Wave number, that is nu bar, and frequency, that is nu. Okay, radiation wavelength is given, right? So can I say that electromagnetic radiation travels with the speed of light, which is lambda times frequency. So frequency can be calculated, frequency can be calculated as 3 into 10 raised to 8 meter per second and 5800 into 10 raised to minus 10 meters. Okay, I am going to approximate this thing as 6,000. I am just approximating it. Okay, so 3 into 10 raised to 8 into 6,000 into 10 raised to minus 10. That is equal to 3 by 6 into 10 raised to 8 into 10 raised to minus 7. Minus 7 gone up becomes plus 7. This is 1 by 2. That is equal to 0.5 into 10 raised to 15. Into what? 10 raised to 15, that is 5 into 10 raised to 14 hertz. So this is what? This is what? Frequency. What is wave number equal to? It will be 1 by lambda. That is equal to 1 by 5800 into 10 raised to minus 10, right? That is equal to 10 raised to this. I can take it. Let us just again approximate it as 1 by 6 into 10 raised to minus 7. So that is 10 raised to 7 by 6. Okay. So that will be something around 1.33 into 10 raised to 6. Okay. Clear? So that is the answer. Okay, now the wavelength of visible region extends from violet to red. Express the wavelength in frequencies. As simple as that. I am just going to give you the equation. C is equal to what? Lambda times nu. The wavelength is given. We need to convert this thing into frequency. So can I say that frequency of violet is equal to what? C by lambda of violet. That is equal to what? 3 into 10 raised to 8 meter per second, and that is 400 nanometer. That means 10 raised to minus 9. So you'll get what? Frequency. You can easily do that thing, right? Clear? And frequency of red is equal to what? This, that is 3 into 10 raised to 8 whole divided by 750 whole divided by what? 750 into 10 raised to minus 9. So you can solve this thing. Okay, clear? Sure. Next, a recent question was asked in 2021. Okay, the particular All India Radio Delhi broadcast frequency of this thing, so that is 1.368 kilohertz. That is equal to 1368 hertz. Okay, the wavelength of electromagnetic radiation emitted is, so we just need to know wavelength. So we know that lambda, C is equal to what? Lambda times frequency. So lambda is equal to what? C times frequency, C by frequency. So that is 3 into 10 raised to 8 whole divided by 1368 hertz. Okay, so if we'll solve this thing, I guess answer has to be what? B, that is 219.3. Okay, clear? So I hope guys we have done with the session. Okay, this might be the last question, or one more question will be pending. The value of Planck constant is this. The speed of the light is this. Okay, which value is closest to the value in nanometer? Okay, nanometer for quantum of light with frequency has to be this. Okay, so say nanometer, and the requirement is also nanometer, so will not change. Speed of light is given, frequency is given, we need to know what wavelength. So this is times frequency. So lambda will be equal to what? 3 into 10 raised to 17 nanometers and 6 into 10 raised to 15. Okay, so 3, 1 by 2, this get cancelled, becomes 10 raised to 2. So that is equal to how much? That is equal to how much? 0.5 into 10 raised to 2 nanometers. That is 50 nanometer. So answer has to be what? 50 nanometer. Clear? Sure. Last question for the day. The value of Planck constant is again this. The velocity of light is this. Which value is closest in nanometer for the quantum? Okay, for the nanometer, again nanometers. Okay, so this time what they have done is speed of light is given in meter per second. This time they want in nanometers. So we'll convert this thing into nanometers. Or first of all, let's calculate in terms of meters and then we can convert. Okay, clear? So see, it's as simple as that. The velocity is how much? C is equal to what? Lambda times nu. What we need to calculate is again lambda. That is 3 into 10 raised to 8 meter per second. And we know that 1 meter is 10 raised to 9 nanometers. Okay, so I can multiply by 10 raised to 9 as well. Whole divided by how much? 8 into 10 raised to 15. Okay, clear? So this will be what? 3 by 8 into 10 raised to 15, 17. So this is 10 raised to 17 and this is 10 raised to 15. It will give you 10 raised to 2 value. So this is approximately how much? 0.48 are 32, around 4 value. Okay, around 4 value. Yes or no? Clear? Sure. So 10 raised to 15 seconds. This should be 4 into 10 raised to 1. 4 into 10 raised to 1, that around 4 8 are 32, yes, around 4, so 4 into 10 raised to 1. Option number C will be the best answer. Clear, guys? Sure. So I hope, guys, today's session you must have understood carefully. If you have any doubts, any difficulties, please make sure that you are going to comment your doubt and difficulties in this particular video. Okay. And electromagnetic spectrum, I will cover this thing next time. Electromagnetic spectrum, or let us cover this thing. It's not a big deal. See, if you'll see 10 raised to 24 to 10 raised to 0, what is this frequency? So can I say that from gamma rays to long radio waves, the frequency keeps on decreasing? And since frequency decreases, if you'll see that wavelength increases. See, 10 raised to minus 16 to 10 raised to 8. So wavelength increases. And also remember one thing, frequency and energy is directly proportional. So energy also what? Decreases. Okay. Visible region starts from 400, okay, to 750 meters. Okay. Is that, or not meters, you can consider this wavelength is given in terms of what meter. This has to be in terms of nanometers mostly. Okay. 450 to 750 nanometers, or 4000 to 7000 Armstrong. So it has to be nanometers. Clear? Sure. So this is all about what electromagnetic spectrum. With this thing, guys, we have done with the session. If you have any doubts, any difficulties, please post it in the chat box, or if you are seeing it in offline, you can post it in the comment section as well. Okay. One more thing, please do not forget to join our channel. Okay, that is Telegram channel. The link is already given in the description box. So make sure that you are going to click on that link and join the group as well, so that you can get the daily you can get the notes that we are doing, whatever we are writing over here, and you'll get the daily updates as well. Okay. And again, if you are new to the channel, make sure that you subscribe the channel, and if you have been connected to us from a long time, do not forget to like the video and share the video as well with all your friends. Okay. So with this thing, guys, thank you so very much for joining this session. God bless you all. Take care. Keep smiling. We'll meet soon.